The Earth needs no introduction. It needs no introduction in part because the Apollo 17 astronauts, when they were hurtling around the moon in 1972, took this iconic image. It galvanized a whole generation of human beings to realize that we're on spaceship Earth, fragile and finite as it is, and that we need to take care of it. But while this picture is beautiful, it's static, and the Earth is constantly changing. It's changing on days' timescales with human activity, and the satellite imagery we have of it today is old, typically years old. And that's important because you can't fix what you can't see. What we'd ideally want is images of the whole planet every day. So what's standing in our way? What's the problem? This is the problem. Satellites are big, expensive, and they're slow. This one weighs 3 tons. It's 6 meters tall, 4 meters wide. It took up the entire fairing of a rocket just to launch it. One satellite, one rocket. It cost $855 million. Satellites like these have done an amazing job at helping us to understand our planet. But if we want to understand it much more regularly, we need lots of satellites, and this model isn't scalable. So me and my friends, we started Planet Labs to make satellites ultra compact and small and highly capable. I'm going to show you what our satellite looks like. This is our satellite. This is not the scale model. This is the real size. It's 10 by 10 by 30 centimeters. It weighs 4 kilograms. And we've stuffed the latest and greatest electronics and sensor systems into this little package. So that even though this is really small, this can take pictures 10 times the resolution of the big satellite here, even though it weighs 1,000th of the mass. And we call this satellite Dove. Oh, thank you. We call this satellite Dove, and we call it Dove because satellites are typically named after birds, but normally birds of prey, like eagle, hawk, swoop, kill, I don't know, kestrel, these sort of things. But ours have a humanitarian mission, so we wanted to call them doves. And we haven't just built them, though. We've launched them. And not just one, but many. It all started in our garage. Yes, we built our first satellite prototype in our garage. Now, this is pretty normal for a Silicon Valley company that we are, but we believe it's the first time for a space company. And that's not the only trick we learned from Silicon Valley. We rapidly prototype our satellites. We use release early, release often on our software. And we take a different risk approach. We take them outside and test them. We even put satellites in space just to test the satellites. And we've learned to manufacture our satellites at scale. We've used modern production techniques so we can build large numbers of them. I think for the first time. We call it agile aerospace. And that's what's enabled us to put so much capability into this little box. Now, what has bonded our team over the years is the idea of democratizing access to satellite information. In fact, the founders of our company, Chris, Robbie, and I, we met over 15 years ago at the United Nations when they were hosting a conference about exactly that question. How do you use satellites to help humanity? How do you use satellites to help people in developing countries or with climate change? And this is what has bonded us. Our entire team is passionate about using satellites to help humanity. You could say we're space geeks, but not only do we care about what's up there, we care about what's down here too. I'm going to show you a video from just 4 weeks ago of 2 of our satellites being launched from the International Space Station. This is not an animation, this is a video taken by the astronaut looking out of the window. Gives you a bit of a sense of scale, our 2 satellites. It's like some of the smallest satellites ever being launched from the biggest satellite ever. And right at the end, the solar array glints in the sun. It's really cool. Wait for it. Boom! Yeah, it's like the money shot. So we didn't just launch 2 of them like this, we launched 28 of them. It's the largest constellation of Earth imaging satellites in human history, and it's going to provide a completely radical new data set about our changing planet. But that's just the beginning. You see, we're going to launch more than 100 of these satellites like these over the course of the next year. It's going to be the largest constellation of satellites in human history, and this is what it's going to do. acting in a single orbit plane that stays fixed with respect to the sun, the Earth rotates underneath. They're all cameras pointed down, and they slowly scan across as the Earth rotates underneath. The Earth rotates every 24 hours, so we scan every point on the planet every 24 hours. It's a line scanner for the planet. We don't take a picture of anywhere on the planet every day. We take a picture of every single place on the planet every day. Even though we launched these just a couple of weeks ago, we've already got some initial imagery from the satellites, and I'm going to show it publicly for the first time right now. This is the very first picture taken by a satellite. It happened to be over UC Davis campus in California when we turned the camera on. But what's even cooler is when we compare it to the previous latest image of that area, which was taken many months ago. And the image on the left is from our satellite, and we see buildings that have been built. The general point is that we'll be able to track urban growth as it happens around the whole world, in all cities, every day. Water as well. Thank you. We'll be able to see the extent of all water bodies around the whole world every day and help water security. From water security to food security. We'll see crops as they grow in all the fields on every farmer's field around the planet every day and help them to improve crop yield. This is a beautiful image that was taken just a few hours ago when the satellite was flying over Argentina. The general point is there are probably hundreds and thousands of applications of this data. I've mentioned a few, but there's others. Deforestation, the ice caps melting. We can track all these things, every tree on the planet every day. If you took the difference between today's image and yesterday's image, you'd see much of the world news. You'd see floods and fires and earthquakes. And we have decided, therefore, that the best thing that we could do with our data is to ensure universal access to it. We wanted to ensure everyone can see it. Thank you. We want to empower NGOs and companies and scientists and journalists to be able to answer the questions that they have about the planet. We want to enable the developer community to run their apps on our data. In short, we want to democratize access to information about our planet. Which brings me back to this. You see, this will be an entirely new global data set. And we believe that together we can help to take care of our spaceship Earth. And what I would like to leave you with is the following question. If you had access to imagery of the whole planet every single day, what would you do with that data? What problems would you solve? What exploration would you do? Well, I invite you to come and explore with us. Thank you very much.